Are we good with that for the first one? What's that face for? No, okay. So I want you to be really specific about this. This is 1 carbon, this is 2 carbons, this is 3 carbons, and tell me what this is right here. That's the bond to the side chain OH. That isn't a 4th carbon. That is a line bonding the 3rd carbon, or the 1st carbon, to the OH group. Are we okay with that? The other way it would be a little bit more clear would be CCCOH, something like that. Draw an aldehyde that has 3 carbons. Okay. That? Are we okay with that? Probably. In line structures, hydrogens are never drawn. So that carbon right there that's doubly bonded to the oxygen, how many bonds does it have to have?
3. Well,
Yeah, so 4 total bonds, right? Yeah. So there's absolutely 1 bond going to that carbon, there are 2 bonds going to that oxygen, and then the 4th bond isn't shown, so what's it required to be? That's your hydrogen. All right, so on ether. We're good with both those? These short ones look a little odd, I think. Carboxylic acid with 3, so either of those. Ester with 3, ester. So that oxygen that's on the right, there's a line coming off of it. What's the line connecting to? It's connected to a carbon. Because if that was a hydrogen, I wouldn't have drawn anything at all. Alkene. There's my alkene. Alkyne. So the real difference between these drawings here is, what does this mean? A line to a carbon. And what does this mean? A bond to a hydrogen. What's this one mean? A bond to a hydrogen. If the carbon is shown, if somebody wrote a C, then any line that comes off of it that doesn't have anything on it, that's going to a hydrogen. But if there are no carbons shown, then every single line you see is a bond to a carbon. And amine, so we'll do this. How come that one's an amine? It's not enough. Definitely need a nitrogen, but what else? The carbon that it's bonded to, what about it? It can't be a C double bond O. It can't be a carbonyl carbon. So if I put a nitrogen on a molecule that's got carbons and hydrogens, as long as that particular carbon it is connected to is not a carbonyl carbon, then it's an amine. So a structure like is that an amine or an amide? What did I just say like 20 seconds ago? What about it? It can't have it at all? So this is an amine because even though there's a C double bond O in there, the nitrogen is not connected to it. The nitrogen has to be actually connected to the carbon that's doubly bonded to the oxygen to be an amide. So this is an amine on the right-hand side. What's on the left-hand side? An aldehyde. Ketone. Either of those? Do we see the difference between those two? What's the important structural difference between those two? More. And the second one, the carbon is directly, the nitrogen is directly attached to the carbonyl carbon. And the one on top, it's not directly attached to it. So the one on top is the amine, and the one on the bottom is the amide. Okay. What's the functional group on this molecule? Carbonyl carbon with carbons on both sides, ketone. This is not a thing. I've seen that written a couple of times. There's no Y. And then what's this one here?
Wait, so there's no Y?
There is no Y.
There's a Y on the thing. That's called the Y.
There's a Y on that?
Yeah.
I should have typoed that. What's this one here? Aldehyde? Looks like the last one, except there's a hydrogen, so that guy right there is just an H, so that means it's an aldehyde. Show a molecule that contains a functional group. Okay. Stop it. What's that? What functional groups? All right, so what is it that the functional groups do for my alkane? So you guys wrote a bunch of papers about biologically active compounds. Did anybody's papers have a compound that was just carbons and hydrogens? Anybody? Why not? Why are there no carbon hydrogen only compounds? Say again? They don't do anything. They're boring as hell. They can burn, and that's about it. So what do the functional groups do to alkanes? Give them function. Okay. Make them chemically reactive. They increase their reactivity. I mean, there's a really big difference between C2H6 and C2H6OH. That first one is just ethane, and I can burn it, and that's about it. And the second one is ethanol, probably the most used drug on the planet, being that that's drinking alcohol. Okay.